Welcome to the short answer part 2 part of this geometry Regents. Let's just get right on into it. Now this first question should look pretty familiar because we were just doing 3D shapes, right? So right here, it's just trying to ask us, this wooden cube is made out of which one of these types of woods? And we're going to do that based on the density. All right, so when we find the density, we'll know what kind of wood it's made out of. So for this one, we just need the density formula. We're going to do density is equal to weight over volume. Now the weight is given to us as 137.8 grams, also known as mass. So that's 137.8. And now we need the volume. Well, since it's a cube, we know volume is equal to the side to the third power. And in this case, that's just 6 to the third power, which is 216. Okay? So now let's just put that into our calculator. 137.8 divided by 216. That's pretty much 0.638. So we have a block, or the wooden cube is made from ash. Kind of weird to make a wooden cube out of ash, but I don't know, whatever, that's the question. Okay, next question. Now, this one's a construction, and I just want to say this. I'm going to do a separate constructions video, and it's really hard to do it on this application, so I'm not going to do this one, but it should be like, boop, boop, and you just connect these three. All right, and it's done, and that's it. But it's really hard for me to do it right now, so let's just say we'll come back to this time. All right, for this one, we are trying to find the distance from B to C. Now, if you're looking at this and you're saying to yourself, well, look at this, there's two congruent angles. We have a 90-degree angle right here for both these triangles, and we have a shared angle. We can use the reflexive property. So we have two similar triangles, angle, similarity. We just need to find a length that's pretty easy to set up. Now, I'm going to say this. Let's start by separating the two triangles, because that's just the best way to do these kind of questions, right? Separate the damn triangles. Sorry for the cussing. All right, well, we know that this is A, this is D, and this is E. That's the smaller triangle. And then we have our bigger triangle, like so. And we know that this is A, this is B, and this is C. Okay? So, what information is given? We know DE is 120 yards, and we know AE is 230 yards. All right? Now, it also tells us that AC is what? Well, it's not just going to be 85. Do not put that. Remember, we have to add these two numbers together. So we get 315. And since we're looking for BC, that's our X. Now it becomes pretty straightforward. Let's just set this guy up. So it's just 230 over 315 is equal to 120 over X. Cross multiply those guys. And we get 230X is equal to, well, let me just get my calculator out because I can't do that one in my head real quick. It's going to be 120 times 315. All right, we get 37800. Divide these guys by 230. And we get X is equal to 164.34. It keeps going. But since it's asking us to run to the nearest yard, we will round this number. So let's write our answer. Remember, we have to put in units. We have to write a full sentence. It's the distance from B to C is, to the nearest yard, 164 yards. Rounding correctly, because we like rounding. We lose points if we don't round correctly on this test. I know what it is. And we answer in a full sentence with the unit. All right, all important things. All right, let's move on to the next problem. All right, for this one, it says prove that ACD is congruent to CAB. Now, I'll tell you this. There's two ways to do this. Well, actually, there's many ways to do this. We want to prove ACD, which is right here, is congruent to CAB. All right? Now, you could do it by proving the triangles are congruent right here. We could do a congruent Cpctc proof. But we could actually do a much easier proof here, all right? I'm going to do, actually, you know what? Let's, trying to think, what do I want to do here? Yeah, let's just do the easy proof, okay? So check this out. I'll show you how to do this proof. So here's our statements, here's our reasons. Our givens is this. 1, ABCD is a parallelogram, okay? And that's our given. All right? Now, since I know that's our given, I can state this. 2, I know that DC is parallel to AB. So I could say DC is parallel to AB. All right? Now, how do I know that? That's a property of parallelograms. Opposite sides in a parallelogram are parallel. And then I can finish my proof by just saying this. Angle ACD is congruent to angle CAB. And I know that because alternate interior angles are congruent. That's the easiest way to do that proof. Now, there's other ways to do that proof. I'll talk them through with you. You could have also done a Cpctc proof. And what I mean by that is this. You could have proven that these two triangles are congruent. There's many ways to do that, but you could state that, let's say, hold on. We know opposite sides are congruent. We know diagonals bisect each other, so we can mark these. And then you have a side-side-side congruence between this triangle and this triangle. And then you could say Cpctc that these two angles. But that's a long proof, right? And let's just do it the easy way, man. Let's just do it the easy way. But I challenge you to try that on your own. I really do. Maybe I'll put it on a quiz. Ooh, bye. All right, 29. We want to prove that these two triangles are similar. All right. Now, it gives us some information. It tells us that RS is 6. It tells us that ST is 14. It tells us that XY is 9. It tells us that YZ is 21. And it says S is congruent to Y. All right. Are these two triangles similar? Prove your answer. All right. Now, it's proving that these two are similar, you just might remember this. There's 3 ways to prove similarity. Side, 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 angle, side, and angle, angle. Obviously, this is an angle, angle, or side, side. We're just going to do a side, angle, side proof. And we're going to write our evidence. And then we're going to write our conclusion. All right? Conclusion. Why do I write like that? All right? And I'm going to put them in boxes just to be super clear about this stuff, okay? Here's my evidence, here's my conclusion. My evidence is going to be, remember that the side ratios are the same. So I'm going to set up 2 side ratios, 21/14. Those 2 sides correspond to each other, all right? I know that because ST is the last 2 and YZ is the last 2, right? Those are why those 2 correspond. So I'm picking the right 2 sides because it's written, the letter order matters, okay? And when you do that, you get 3/2. All right, that's also equal to 1.33333, okay? Now we're also gonna do 9/6, all right? 9/6, which is, guess what, 3/2 as well, which is also equal to 1.333. And then finally, we're gonna state which angles are congruent. Angle S is congruent to angle Y. See, I have 3 pieces of evidence here. This is all the evidence I need. I need 2 sides with the same ratio. I always show the ratio, and that I have 1 angle that's congruent. And so I could just say triangle RST is similar to triangle XYZ because of side angle side similarity. All right? The evidence is the key part here. This is what you guys usually forget. You always need to put your evidence before making the conclusion. If you just said side angle side similarity, you get no points on this question. You have to show that the ratios are the same because that's the key to similarity, and that you actually do in fact have 1 angle that's congruent. Just got to restate it, guys. Pretty straightforward. Oh, this is one of our favorites, okay? In the diagram below, we have triangle ABC and XYZ graphed, all right? Use the properties of rigid motions to prove why triangle ABC and triangle XYZ are congruent. Now, there's 2 parts to this. 1, you have to state the rigid motion that will map them onto each other, and that's going to be a rotation of 180 degrees, clockwise or counterclockwise, doesn't matter, around the origin. And then we have to use the properties of rigid motions to state why they are in fact incongruent. So remember, there's 2 steps to this. So first we're going to write this. 1, a rotation of 180 degrees counterclockwise around the origin maps triangle ABC onto triangle XYZ. All right, and notice how I put the degree, the direction, and in the center of rotation. I used all three. And then my second part of this is going to say this. A rotation, remember, is a rigid motion. And rigid motions preserve side lengths and angle measures. All right, because the sides and angles didn't move, didn't change size when I map them onto each other, they have to be congruent, right? Because they fit perfectly right on top of each other using a rigid motion. Dope, dope, dopey, dope, dope. Great job. Yeah, this is our last problem. All right, the endpoints DEF, D is 1, 4, F is 16, 14. Determine to state the ratio that put where E is to make the ratio 2 to 3. Now, you might remember this, but what we have to do is actually graph this. All right, so come with me. We're going to go over to the graphing part, and we're going to graph this out, and I'll show you how to do it. Okay, so come on over. All right, so we got only. All right. So let's just write down the information that was given to us on this question, okay? It told us that we have D, which is 1, 4, and we have F, which is 16, 14, okay? Now, all you gotta do is graph those points, so I'm just gonna make a rough, really rough sketch here, guys, all right, of these 2 points. So we got 1, 4, which is right here. This is point D. And then we have 16, 14. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. And then 14 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, this is point F. All right, we're going to connect that with a line to the best of our abilities, like so. Now, we want to get a ratio of 2 to 3. The ratio that we're going to have is 2 to 3. So you might remember this, but the first step is to count the distances. So to get from D to F, I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Write that down. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? Now you add your ratio, you get 5. And remember, so we're going to take those two numbers, 15, divide that by 5, and 10, and divide that by 5. All right? 3 and 2. A lot of people remember up to this point, but the next thing you have to do is just use these two numbers to count. And what that means is this. So now I'm going to go, instead of 15 to the right, I'm going to go 3 to the right and then 2 up. So I go 1, 2, 3, 1, 2. That's my first point. 1, 2, 3, 1, 2. And all I'm doing is cutting this into equal pieces. Okay, 1, 2, 3, 1, 2. And you'll see now I have 5 parts. So I've just cut this line into 5 equal parts. That allowed me to do that. Now I need a ratio of 2 to 3. So let's see. I have 1 piece, I have 2 pieces, I have 3 pieces, I have 4 pieces, I have 5 pieces. What we do is this. We count like so. Here's 2 pieces, here's 3 pieces, right? So the point E would be right here, which is at point, woo, it's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So this point is at point 7, 8. Okay, so I'm not going to scroll back, but I'll tell you this. You actually have to redraw all of this. They don't grade your graphing paper. So this has to be redrawn onto that paper without the graph. And then you say point E is 7, 8. All right, that's it for part 2. Covered over and out. Peace out, yo.